Well, welcome everybody. We are meeting today to discuss the topic of bridging the rural digital divide with space. And first of all, let me start by thanking the National Academy of Engineering for hosting this meeting and allowing these distinguished panelists to basically share information on this important topic. So my name is Alison Brown. I'm a member of the National Academy of Engineering, and I was it was brought to my attention, this problem, through working with some of the different organizations that you're going to be hearing from today that are trying to expand rural broadband access to complete coverage across the United States. Can we have the next slide, please? The rural digital divide is very real. And while obviously in less developed nations, this is an even more extreme problem, what I'd just like to do is bring to the audience attention how serious this problem is still here in the United States. Broadband was a lifesaver during COVID-19. It enabled people to work, learn, and receive healthcare online. But the Federal Communications Commission reported in 2021 that nearly 7 million school children lack internet access at home. And unfortunately, this gap has put those children back a number of years in their education. There's been a significant investment in building broadband across the United States, but fiber networks are costly to install to serve low-density populations. And as a result, rural residents are still struggling to get access to broadband internet services, I should say affordable broadband internet services, which is creating a digital divide. There are new broadband space services coming online, and that's the subject of this panel discussion, in particular, how these new services could address the rural digital divide. Next chart, please. The FCC, as I mentioned, has been making a significant investment in building out broadband nationwide. And in particular, they've set up this map that anybody can log into. And rather than their older system where the broadband providers self-reported their coverage areas, this map actually allows individuals to go in and challenge those assumptions. So the map is evolving. I'd certainly encourage everybody to go look and see if it is accurate for their locations. And it's very easy to use. You can put in your address, click on it, and it allows you to enter what internet services you have access to at your location. You can see here the white spaces are quite significant. And these are areas where there is no broadband coverage in the rural areas. Next chart. What I'd like to do, thank you. What I'd like to do is just highlight, we're going to hear first about broadband coverage in Colorado. And Colorado is where I live. So I'm very familiar with this particular issue. And this map basically shows that while the metro areas are covered, the rural areas, in particular the western part of Colorado, are not. So what I'd like to do, first of all, is introduce our first panelist. Her name is Brandy Reitter, and she is the Executive Director for the Colorado Broadband Office. And she will be talking about initiatives that have been going on in Colorado and also nationwide to address this broadband gap. So, Brandy.
Thank you, Alison, for that really nice introduction, and just thanks to everybody who is on the call today. And I'm happy to talk about Colorado Broadband and what we're doing in our state to bridge a digital divide, and how the application of various space technologies are definitely part of that equation. So if you'll just bring up the slide deck, I'll go ahead and jump right into it.
Yes, give me one moment. I had a spam call that I needed to reject.
Okay.
Okay, so let's.
So So while that's coming up, so I'm the executive director of the Broadband office. I've been in this role for 2 years. I came from rural Colorado as a town manager in local government. And I will tell you that broadband was a huge issue during the pandemic. It was obviously an issue beforehand. And so I'm just really excited that the federal government, as well as the state of Colorado, are making significant investments in bridging the digital divide so that folks aren't left behind. So next slide. So broadband is essential for Colorado residents to thrive. Broadband enables essential activities of Colorado residents and improves society through different channels such as healthcare, public safety, education, government services, and economic development. You know, as a state of Colorado, we see broadband being the key intersectionality of everything that we do in our daily lives. We no longer live analog lives these days, and everything it relies on having good connectivity. Next slide. So how does Colorado compare to other states? We do have work to do in Colorado. Other states obviously are worse off than we are, but we're in the middle of the pack in terms of lack of access. We rank 23rd in terms of high-speed internet availability, with 89% of households having access to 100 over 20 or greater speeds, megabits per second. We rank 7th in high-speed internet adoption, with 76% of households in Colorado that are subscribed to high-speed internet. Second in device access, with 85% of households having a computer at home, and then 20th in access to affordable plans, with 87% of households having access to plans at 25 over 3 megabits per second or higher for $60 a month or less. And then lastly, we ranked 11th in equitable access for marginalized populations like African Americans, you know, people that are economically disadvantaged, and Latinos. So we have a gap there, and really the lack of access impacts marginalized populations, economically distressed populations, more so than other populations. Next slide. So what did Colorado do about this? You know, broadband starts with a vision. And so when we've encouraged a lot of our communities to start there, what do you want to do? What technologies do you want to apply to help bridge the digital divide? So in 2022, the governor our office developed a broadband roadmap for the state of Colorado that really speaks to universal coverage. So connecting 99% of Colorado households to high-speed internet by 2027. There's basically 4 components to this strategy. It's build a network for future generations. Obviously, fiber is part of it. A lot of our federal funds prioritize it, but really it's about the most fast and reliable internet connectivity that we're prioritizing. And the broadband office is a technology neutral office. So I have said that publicly. We think that it's going to take multiple applications of different technologies to bridge the digital divide in our state. We've invested in mapping analytics to help us understand where those needs are. We're supporting the industry by expanding workforce development because there are labor shortages in the telecommunications space. The next goal is expand digital equity, inclusion, and adoption to achieve affordability and access to digital literacy. It's not enough to have access to broadband if you don't know how to use it. There's a gap there. So we're coming up with various programs to help educate people, make those devices accessible to those that need it. And then strengthen resiliency across Colorado communities through broadband. We're doing this through a lot of stakeholder outreach and public-private partnerships. And then lastly, the last goal is enable Colorado to thrive by fostering and supporting a digital economy. So, you know, looking at innovations and innovative technologies and practices for how we bridge a digital divide, leveraging technology to improve government services. So those are all things that are in this strategy, and it's really setting the stage for how we implement our federal funding. Next slide. So how much money are we talking about? So the state of Colorado has been really generous about our funding. You know, through the American Rescue Plan Act, this happened in the midst of COVID. We allocated $75 million in state and local fiscal recovery funds to broadband connectivity. We're in the process of executing capital projects funds. The state was allocated $171 million to broadband for connectivity. And that's just with the U.S. Department of Treasury. we have the Infrastructure Investment and Jobs Act. And so this is where the lion's share of our funding is. And so just this year, we were allocated $826.5 million in the Broadband Equity Access and Deployment Fund, which is BEAD. And we were allocated $21 million in state digital equity grant funds. So we will be doing a round of digital equity grants next year. And then the state was awarded $2.7 million in middle mile grant connectivity, not through the state, but through a provider. So we're seeing a lot of investment, and this is just one piece of the pie. There's other programs through the USDA and tribal connectivity programs. So we're seeing a lot of influx in money invested in broadband in our state. Next slide. So how does space play a role? Like I said, the Car Broadband is a space technology, technology neutral office. And we think that, fiber isn't going to go everywhere. It's a reality. We have beautiful mountains, rivers, railroads. We have a lot of really great soils that make it really hard to build infrastructure in our state. We have many high cost areas. And I think space technology has a really great role to play, but not also in our rocky terrain. But when you're talking about large swaths of rural communities, space can cover a lot of folks really easily. And so we'll be looking at these space applications as we roll out our broadband programs and looking at our high cost area designations, because that's really where I think space has a role to play. So what does that mean? So there's a couple of technologies that I think would be really applicable to help Colorado achieve or bridge the digital divide. The first one is geostationary satellites. So, these are satellites, they're positioned in fixed locations above the Earth, which can provide broadband coverage over a large area. And, companies like HughesNet and Viasat and many others are in this space making and developing technology to help deploy broadband and making it more accessible in rural and remote areas. We also have low Earth orbit satellites. So these are also technologies that we think would help bridge the digital divide, such as those deployed by companies like SpaceX, which is Starlink, OneWeb, Amazon, which is Project Kuiper. These really aim to deliver high-speed, low-latency broadband to underserved areas globally, really not just in Colorado. But these satellites offer improved connectivity compared to other geostationary satellites. So when we look at our mix of technology, especially in our high-cost areas, these are definitely applications that, I think help bridge the digital divide. Next slide. So there's other technology applications that I just want to hit on that also could play a potential role in bridging the digital divide. So we have Earth observation for infrastructure planning. So these are spaceborne remote sensing technologies, including satellites equipped with high-resolution cameras and radar systems. They help in assessing terrain, population density, and infrastructure distribution. This information is really aids the planning of deployment for broadband infrastructure pretty efficiently and effectively. And I regularly have conversations with industry partners in this space. There's a lot of infrastructure planning that's happening. Where this really helps a lot is like in the public safety, helping our federal partners cover areas of land that there's not really a residential piece to it or a commercial piece to it, but it's more of like for public safety, search and rescue. The next one is global navigation satellite systems. These are spaceborne remote sensing. Actually, sorry, they're not. They're systems like GPS. They not only provide navigation services, but also contribute to the synchronization and coordination of communication networks. This is critical for proper functioning of broadband systems. So we see like a lot of, fire districts and utility operations using these types of applications, GPS and so forth, and our federal partners as well, and public safety. The next one is inter-satellite communication. So these are satellites equipped with satellite communication capabilities that can relay signals from one satellite to another, create a network that can cover vast areas. This helps in overcoming geographical obstacles when we're looking at expanding broadband. And then we have emergency and disaster response. So space really supports this really well, as I alluded to. So during emergencies or natural disasters, terrestrial communication infrastructure can be used, maybe used to help with damaged and disrupted services. These satellites provide a reliable measure of communication, so enabling broadband services for emergency responders that are responding to affected populations. So we have a lot of fires in Colorado. We have floods. We have avalanches. We have all types of disasters, even hailstorms. And so, you know, a lot of these technologies really help with public safety response. And then we have space-based networking experiments, which I've gotten a little bit into in my role as the broadband director. But I'm learning a lot about research initiatives involving deploying experimental communication systems in space. And I know I've talked to Alison about some of these applications. But so a lot of the experiments that are happening will help inform the best technology of the future. And I'm really excited about that. And it's definitely adaptable to broadband technologies. And then lastly, the global connectivity initiatives, like I said before, you know, this isn't just a Colorado application. This can help nations across the world that lack access. So organizations such as the International Telecommunication Union and the United Nations are working on various initiatives to leverage space technologies in the for global connectivity. And these efforts actually aim to bridge a digital divide for broadband services for people around the world. So in summary, space technology contributes significantly to broadband deployment by providing innovative solutions to overcoming geographical challenges, which the state of Colorado definitely has, and enhances our communication infrastructure and extends connectivity to remote and underserved regions. So we're really, as the state of Colorado, we're really excited about the work that's happening in this space, and hopefully we can partner with those, the industry working on it to help bridge a digital divide and expand service across our state. So that's my presentation, and thank you so much for allowing me the opportunity to share with you what we're working on at the Colorado Broadband Office.
Great. Thank you very much, Brandy, for setting the stage there. I'm sorry. Can I do a sound check? Is my mic? It is. Thank you. Great. All right. Well, we're going to move into the technical section of our presentations. So just questions are welcome. We're going to hold them to the end, and then we're going to do a Q&A session at the end of the presentations. So after that great stage setting from Brandy on the problem that is being faced in rural Colorado, and obviously extends to many other rural areas, what we're going to hear next is from Edward Oughton, who is an assistant professor at data analytics at George Mason University. I asked Edward to speak because he has done some interesting studies on where space is applicable and also where it may not be the best choice for serving the broadband community. So we're going to hear those two sides of the equation first, then we're going to move into a panel on the evolving rural space broadband services, what's currently available, and also what will be coming along that can address this digital divide. So, Edward, can I turn over to you?
Yes, thank you very much, Alison. Great, I'll share my screen now. So hopefully you should be able to see this presentation. Great. Thank you very much for that introduction. Thank you for inviting me here today. I'm going to give you a bit of an overview of the work that we've been doing on LEO, particularly where the engineering begins to meet the economics, which is kind of critical for the kind of overcoming the digital divide, essentially. So as part of the motivation for this, I'll be focusing on the who, the where, and how of universal broadband, but specifically with regard to LEO. Okay, so before we get into those LEO constellations, we need to just kind of zoom out a little bit and consider the kind of picture of where do we need to invest, who's not connected, and I'm going to do this from a global perspective. So obviously we're going to focus on the US, we've just had Brandy give us that overview for Colorado, but essentially globally, actually most of the unconnected folks are not in the United States. So I'm just going to start at the high level and then we're going to zoom in a little bit. So essentially essentially, we produced a model recently, which we just published for the International Monetary Fund, which looks at investment in countries around the world at the subnational area. So essentially, we're interested in, well, how much would you need to invest there to provide a decent broadband service? And essentially, the outcome of this is that the reality is that many parts of the coastal areas of the United States have quite good connectivity, but then obviously you get to quite rural areas, it's not great. Other parts of the world, Western Europe, reasonably well connected. The coastal areas of China, very well connected. Obviously, Japan, parts of India also well connected. But then we have quite high latitude regions which are really quite poorly connected, at least via terrestrial infrastructure. And then also areas, large swathes of the Amazon rainforest or the desert in sub-Saharan Africa, where essentially you have very little existing fixed infrastructure, and therefore satellite's just going to be a necessity in order to provide broadband to those people there. So this is kind of the picture that we're working with. If it's not grey, it's generally unconnected. If it's dark blue, it's very much a satellite area for the future. Okay, and just one more slide on this before I finish. We have however many, tens of millions of people who need improved broadband in the US, but ultimately we still have about 1.5 billion people in emerging and developing Asia, which is still completely unconnected from the internet. And that's essentially going to drive a lot of the policy focus internationally over the next decade, essentially, and then also about 750 million people in sub-Saharan Africa, also completely unconnected. So while we have a lot to do with the money that we've got from the government to spend on particularly on fixed, but also on satellite broadband infrastructure potentially over the coming years, the problem is also global. Okay, so within this research that we started about 3 or 4 years ago, the approach was essentially that we were already modeling terrestrial cellular networks and other types of wireless communication networks. We didn't model satellite. We were interested in LEO. We thought we would begin by developing an open source modeling platform that basically allowed us to show people the assumptions and the input parameters that we have used based on the thesis that if we published something and it was wrong, we could correct it later, and that was better than having a closed box model essentially. So we focused on the 3 LEO constellations that were kind of at the forefront of our mind at the time. So apologies if we didn't model your constellation, but we focused on Kuiper, OneWeb, and Starlink. Obviously, there's been some merger and acquisition activity in this sector, particularly with regards to OneWeb in recent years. But generally, these are the phase 1 constellations which we've been focusing on. I say phase 1 because obviously phase 2 is kind of going to see this large jump potentially from thousands of satellites to tens of thousands. So that's something definitely for the future to consider. Obviously, OneWeb in its phase 2 will see it kind of get to a similar density to the phase 1 constellations for Kuiper and Starlink. So this is kind of the background for the satellite networks that we've been modeling. Okay, so that first paper, which we published now in 2001, essentially produced these kind of techno-economic analytics that allowed us to look at the supply side, so how much capacity could be provided from the kind of the radio setup, the radio link budget of each of those constellations. And then we would basically use metrics on the demand side to understand how much per user each individual was essentially able to get. So I think my role here is, not to speak in depth on each of the constellations, because we have people who are able to do that. I'm here as an independent party to just report on what we've done in this modeling work. So obviously, these constellations provide amazing capabilities. They also have some disadvantages and some limitations. So I'm going to bring those to the forefront as well. So the way that we kind of did this was we had this demand module which looked at how many people are likely to adopt in each area. Okay, so that's driven by scenarios of adoption, also by population density, so how many people are in each place. And then we also consider the average revenue per user, so how much people can pay. So that's the demand side. And then on the supply side, we had this engineering simulation model which basically looked at the downlink radio channel, essentially. So how much spectrum is available, what the spectral efficiency is, what the conditions of the transmitter and receiver are. So obviously there's 3 ways to enhance the capacity of a radio network, a wireless network. You improve the spectral efficiency, so more bits per hertz. You provide more spectrum, so you provide more spectrum bandwidth, or you build more assets. Okay, so that could be satellite assets in this case, or in terrestrial, it's build more cells essentially. So that's kind of the theoretical background for the simulation model. And then we had costs. So we had network architectures for these 3 different constellations that had to be built, and we had costs produced from open sources. For some of those, obviously that's going to differ from reality, but this is all open source, so happy to take any corrections on what we've done. So essentially what we get out of that model is a kind of geospatial understanding of where these particular technologies are relatively good. In fact, very superior to some of the previous technologies in providing broadband services. So if you look at some of the low and high latitude locations here, users under the assumption sets that we've used here, and we can debate those over a long period of time. Essentially, they're getting a very high level of service potentially. So, 100 meg to a remote location is very impressive. But I think the key point here is that there's been a lot of hype in the sector. Some people were saying there was going to be a gig per household from some of these constellations. So we're just putting a little bit of, reality into the modeling work here to say these are impressive technologies, but it's not quite going to be a gigabit per premises, essentially, by the time you look at how many users are in each satellite coverage area. So there's some minor differences between the constellations, but that's usually due to the density of the network assets. And each of the constellations are kind of targeting their own, business model approaches, market segments. OneWeb obviously has a slightly different approach to market than the other two that we've looked at here. So some of that is being driven by population density, so the high and low latitude regions, lower people, or areas of desert or rainforest. But then there's also coverage holes, for example, in parts of India, which have very high population density. So these are some of the prime areas that could also be very relevant for satellite, as well as parts of sub-Saharan Africa. Okay, and then just to close on the kind of analytics, we have produced a new working paper which kind of picks up on some of the limitations of our previous work. So, we've been going at this for a couple of years now. In general, when you look at the aggregate metrics for how much capacity these satellite networks can provide, it's very impressive. But then when we get down to actually trying to put some of the more ambitious adoption scenarios through those metrics, the numbers come out a bit more sobering, essentially. So obviously these are averages and don't reflect what it would be like, for different subnational areas. But we start to see much more modest numbers by the time we kind of expose them to the number of, the high level adoption scenarios that are in some of the business plans for some of the constellations. So here we're talking about, 10 meg per user in a busy hour if everyone starts to use the network at the same time, which is impressive, for how many networks, how many users it can carry. But, these networks can't break the laws of physics if you begin to overload them with lots of future users, essentially. Okay, so my key message as I wrap this up is that LEO is fantastic. It's an essential part of our connectivity toolbox. It'll be really important for providing universal broadband in high-income countries, but also for delivering sustainable development goals, particularly in low and middle-income countries where there's very little existing fixed infrastructure, terrestrial infrastructure. But also, these networks can't overcome physics-based limitations, and that kind of comes through with the results that we've been picking up. So obviously we have limited spectrum. That's not a problem that we're going to solve too quickly. Obviously there will be spectrum sharing there. We're also limited by things like the Shannon bound, so how many bits per hertz we can fit on a radio wave. And there's also issues, which obviously I don't get into here, about maximum orbital carrying capacity, how many networks we can support globally, obviously, because it's not just about US networks or like high-income country networks. Other countries are also trying to get to this space. But I think just to close, just to reiterate what some of the LEO operators have said, this is about trying to get to those very hardest to reach locations, the bottom 1, 2, 3% of hardest to reach locations per country. And I think that they have an important market presence. So thank you for your time. I'll pass back to you, Alison, and I'll look forward to taking any questions.
Excuse me, I didn't realize I was muted. Thank you very much, Ed. That was incredibly informative. Kind of my takeaway from this is obviously large capacity, dense consumer areas, the space services are challenged to service. But what I find interesting is when you look at the maps where you're showing the demand, obviously these areas, very rural space, sometimes may be the only option. One of the key questions that have to be considered, though, of course, is many of those rural areas are also economically disadvantaged, and how can access be made affordable for them? So we're going to pivot now into the panel that's going to talk about current and evolving rural space broadband services. So let me briefly just go through and introduce each of our distinguished panel members. First up, we're going to have David Goldman, who's the Vice President of Satellite Policy for SpaceX. Next, we're going to hear from Howard Stanley, who is the Vice President of the Americas for OneWeb. Next, Michele Beck will talk to us, who's the Senior Vice President for Canadian Sales at Telesat. And then we're going to close out with Margo Deckard, who's the Chief Operating Officer at Lynk Global Inc., who in particular, while they're not providing broadband, are focusing on some interesting models that are providing direct to cell phone future coverage, which also has an important part to play, particularly relating to emergency services, which Brandy referenced as being an area that again is undercovered in rural areas. There are many areas that you don't get access to cell phone coverage. So next then, I would like to turn this over to David Goldman, who's going to tell us the current services and future services are going to be offered by SpaceX.
Hi, how are you? My name is David Goldman. I'm with SpaceX. I guess first off, thank you so much for having me and giving us the opportunity to speak. I really do appreciate it. Also, it's great to come up after those other two presentations. Colorado is one of my favorite places to go, so it's fascinating to hear how things are going there and to think about ways that we can improve connectivity in Colorado. And that report, that summary was really interesting. I'd be interested to maybe kind of share some analysis from our engineers on some of that. I think some of the assumptions that went into that may not actually match our actual operations, and so that would be an interesting thing to follow up on. But to move on to Starlink and what we're doing, I guess if you wouldn't mind, yeah, thank you, flipping to our slides. I wanted to start with giving a little bit of background about the company overall, because to understand how the economics of how our constellation works, to understand that you have to first understand a little bit about the launch business. So I'm going to talk a little bit about launch for a couple minutes and then move on to how that enables Starlink, which is our broadband constellation. Next slide, please. SpaceX started in 2002. I know that may be earlier than a lot of people have thought of, but we've been around since 2002 with the primary objective. The mission of the company is to make humanity interplanetary. Can we move to the next slide? We've done this. We have 3 primary launch vehicles that we are started as a rocket company, as a launch company. You can see on the left-hand side there is our Falcon 9. That's our workhorse rocket. There's 2 versions of that sitting there. One is that you can see, one has the Dragon capsule at the top, and that's how we bring cargo and astronauts to space. And then on the right is the one with the fairing on it. That's those fairings, that's how we encapsulate satellites to bring them up. And then in the middle is Falcon Heavy, which is one of the world's most powerful rockets right now. That's essentially 3 Falcon 9 strapped together for extremely heavy payloads. And then on our right, on the right side, is our next generation vehicle, which is Starship, which we're hoping to have another test launch any day now to bring that. And that will be the world's most powerful rocket, and hopefully is the one that's going to bring us to Mars. We can move to the next slide, please.
Dragon, SpaceX, ComTrack, ground stations.
Integration 4 is go for launch. Launching SpaceX.
3, 2, 1, 0.
ISS out the window, which was pretty neat. The largest window ever flown in space.
We have liftoff.
Cool, thanks. So can we flip to the next slide? Thank you. So for the record, we've only launched one car into space, so that was a little misleading to make it look like we did a lot, but we've only done one car, and at the end, we have not yet put a colony on Mars. That is our future hopes. But one of the keys that you could see in that video that makes low Earth orbit NGSO constellations economically viable is that we can land those rockets and reuse them. Some of our rockets we've now reused 17 times over. And so what that means is that, I mean, think about it with spaceflight. If you had air flight, if you had to throw out your airplane after every flight, it would be much more expensive to fly. Same thing goes with rockets. When you have single-use rockets, it becomes much more expensive. If you can reuse your rockets, you can bring down the cost of launch significantly. And that's key because for low Earth orbit satellites, and I'll have another slide on that in a second, but low Earth orbit satellites, you're much, much closer to the Earth, which means you need a lot more satellites to be able to actually have global coverage, as opposed to geosynchronous satellites, which are 60 times further from the Earth than the low Earth orbit ones. So what you're looking at right there is a stack of our Starlink satellites. So we have leveraged our launch capability and our ability to reuse rockets to launch our own satellite constellation. We now have over 5,000 satellites that we have launched. We now have global coverage anywhere in the world, including the North and South Poles. We serve the researchers down in Antarctica. And so you can see what we do is we launch a stack that's actually 60 satellites right there that you can see in that image. That's two stacks of 30 stacked right on top of each other. We can go to the next slide. Thank you. So what you can see here is why that matters, why being closer to Earth makes a difference. Is obviously this is dramatically slowed down, but even at the speed of light, to get a signal up and back to a geostationary satellite can take 600 to 700 milliseconds, which makes it really not super useful for things like real-time video. Doing the kind of video that we're doing right now is not really viable on a geostationary satellite because there's too much latency. As opposed to you can see for the low Earth orbit satellites to the left, when you're that much closer to the Earth, you can have a lot more back and forth, and the latency goes way down to about equivalent to what you get with a terrestrial system. I think we can flip to the next one. So what that means is that we have a whole bunch of new capabilities that we can do with this system. Essentially, you don't need ground infrastructure anywhere nearby, which is what's key. So in addition to the rural broadband, And I guess let me pause on that for 1 second. One of the things, our satellites are everywhere. We have coverage everywhere all the time, and that actually reverses our economics. So compared to terrestrial, so terrestrial broadband, deploying infrastructure in any given place is very, very expensive. So you want to go to dense urban environments to start with, where you can get as many people on your infrastructure as possible, and then you build out to rural areas, and eventually you get to a place where you actually can't pay off the infrastructure anymore. Because our satellites are everywhere, always, anyway, our economics are the opposite. We're actually going to remote areas. Actually, it is a better economic incentive for us. And as we deploy more and we build bigger and better satellites, we can then push in towards urban areas from there. But it also, because we don't need the ground infrastructure and we can bring basically urban quality broadband anywhere and quickly, it enables all kinds of different use cases that you may not have thought of. So my personal favorite one is this one that's in the top left, which is that's a mobile clinic, iClinic. And what that does is that can roll into low-income neighborhoods. It uses Starlink to connect to broadband. And then what they'll do is they'll work with people in the community to do eye tests, then upload the prescriptions to the net, and then download the plans for a laser printer to be able to print up the glasses on the spot. Not laser printer, a 3D printer, sorry. 3D printer to print the glasses on the spot. And you can just roll in anywhere and be able to do that. But we also, when we say connecting schools, that's actually a school that's on an island that you can only get to by boat, that's never been able to have broadband before. In the bottom left corner, that's an emergency test that we were doing of what happens in the middle of the ocean if there's, you have to recover astronauts. If there was some problem with astronauts coming back to Earth, then there had to be an emergency evacuation. We're using Starlink to be able to provide broadband to provide connectivity in that case. And in the bottom right, that's in West Virginia. When there was a mine disaster, we provided the broadband that they were then able to bring signal down into the mines to be able to do the rescue operations. Next slide, please. So one of the things, I did not want to let this go without kind of mentioning some really important parts of how we need to be able to operate in space to make sure that all of these systems can operate and continue to operate going forward. Obviously, our entire business depends on it, but it also is just the right thing. The only way that we're going to be able to maximize the utility of space is if everyone is responsible. And number one thing is actually transparency. You'll hear a lot of people talk about all these really complicated ideas. But the most basic is to let everyone know where your satellites are. Believe it or not, that sounds just intuitive. It's not what everybody does. We need to do better as an industry about sharing information about where our satellites are with each other at all times, so we can make sure that we are doing appropriate collision avoidance. I can tell you on the SpaceX side, we take on the responsibility to avoid everyone else's satellites, but to do that, we need to have some information about where they are. We also have volunteered. We do a public report every 6 months on the health of our constellation. We zoom out from a single satellite and a single maneuver to how is the constellation doing overall. We encourage all operators to do the same thing. We think that is just a better way for the public to be able to hold us all accountable. And we put together a set of best practices along with other operators like OneWeb and Iridium, and we are encouraging all operators to sign on. These aren't your normal kind of industry best practices that are kind of like, here's the status quo. This is a lot more aspirational and forward-leaning, and we think to be able to maximize space, we need to be able to all sign on to these more aspirational goals. Next slide, please.
Yeah, this is crazy. A lot of people don't realize this, but
it is now mounted.
This little dish sits outside.
Becky, tatry na namin yung Starlink.
snow, frost, high winds, you name it.
Funciona bastante bien. Myself, roaming. Got my pole-mounted Starlink here.
I do.
Starlink unboxing.
Starlink. Did you order?
Starlink, go Falcon 9.
What? Until commission.
Satellite Wi-Fi right here. We're going to be using in emergency situations when people need to communicate.
In the middle of nowhere, I'm playing on my computer off of a battery online on the Starlink.
And so that was it. I think what your biggest takeaway is that I'm very aware that videos of rockets is way more interesting than me talking. But thank you very much for having me.
Thank you very much, David. So our next panel member is, excuse me, Howard Stanley, who is going to be talking about OneWeb, current and planned activities. Howard?
Hi there. I'm just going to make sure that I can share my deck here. Just give me 1 second. Where is it going? Oh, there we go. Okay. Can you see my screen? And you can hear me. Perfect. All right. So as advertised, I'm Howard Stanley, VP of the Americas for Eutelsat OneWeb. We were OneWeb until about 6 weeks ago. Then we merged with Eutelsat. We are now Eutelsat OneWeb. What that means roughly is that we are now a global satellite connectivity company as part of Eutelsat Group that has 37 GEO satellites and a LEO constellation with over 630 satellites in orbit today. And we are in active service for the LEO for probably 2/3 of the world, I guess, with the last third coming online around the equator later this year and early next year. As a global company, there's 1,700 people in 20 locations, 50 nationalities. We are super international, actually. This comes up in every meeting. We have a market cap of 1.15 billion euros, and we're looking to double that because of the expected growth of LEO services. I think the way I would talk about this, the whole conversation actually, is that the economics of the space industry have been completely rebaselined. In fact, because of Starlink, which is frankly the best advertiser for LEO services ever. So we have to thank Starlink for educating everybody on the market. We actually have used SpaceX rather as a launch partner. I got to go to a launch in California with Iridium and OneWeb doing a ride share on a SpaceX rocket. It was a fantastic experience, and I think it does kind of highlight that the cornerstone of the space industry is in fact cooperation. It's a very small industry, and there is a lot of sharing of knowledge. And I think anytime you can get people to agree to use a satellite service, the whole industry grows. So we think of that at OneWeb at least as a good thing. But what's happened because of advancements in LEO in particular, it has lowered the entry cost of satellite services. So it would actually be really interesting to talk to Edward sometime about some of the models that he had looked at, because there's a good chance that a lot of the economic models have changed even in the last 6 weeks, for instance. Because we have both geostationary and LEO assets, we look at things often in a multi-orbit scenario where we look at blending the two services. Not everything needs super low latency, so you do have an opportunity to add more capacity and lower certain costs by blending the two services, which I'll comment maybe a bit more fully on later. Our view is that we've got a very broad B2B mandate for our company. We don't really go direct to consumer. And so, whereas I guess by comparison to Starlink, there's sort of a 1-to-1 ratio of customers. We're a one-to-many by virtue of the fact that we often, in the context of community broadband, will go to a community where they may have a pre-existing last mile service, and we will be an input into that. And I can show you what that looks like in terms of a networking diagram shortly. But we do cover a lot of different B2B environments. And so I think in some of Edward's research, probably some of that market penetration is reflected by the fact that we probably are more likely to be addressing businesses than people in some scenarios. That notwithstanding, what I'm going to do is take just a quick step back and give you a little context about me personally so you can understand some of the opinions that I'm going to inform you of shortly. I'm Canadian. I'm originally from an island called Grand Manan, which is in the Atlantic Ocean in the Bay of Fundy. It's in the province called New Brunswick. I grew up there. I eventually moved to Ottawa, which is our beautiful nation's capital, and I've lived here since, I don't know, 1989. The interesting thing about Grand Manan is it is a fishing island. I would say when I was there, at least growing up, 100% of everything was in the fishery. This was all my relatives. On the right is the Star Weir, which 6 generations of Stanleys have fished for what ultimately would become Brunswick sardines. We have since expanded our portfolio to include salmon farming and lobster fishery. Why do you care? Well, because this island had no connectivity for a very long time. Until, in fact, my father connected it, which is a long story, which I'll tell you in a minute. But most recently, this island had its only bank branch closed down. And so the only way you can do your banking, if you're one of the 1,200 people on this island, is over the internet. And some healthcare services have recently left the island. And so more and more being connected digitally is super important for the people that I am related to who live on this island, yet are part of the vital Canadian economy that is maritime oriented. There's a statistic from StatsCan that says 1 in 10 Canadians is a participant in a maritime related activity, which actually kind of surprised me. My father left the island and started a cable company, and that cable company ended up connecting 100% of New Brunswick's cable subscribers, 265,000 of them. And I grew up working for this company, climbing telephone poles and digging ditches and that sort of thing, and got a very hands-on education and network building. We also owned a bunch of radio stations. We owned a cable company in the UK, but very much where I come from is sort of hands-on, how do you connect people? And that was really content purposes, but it eventually included internet. And to my knowledge, we built one of the first sonnet rings in North America, which is, the synchronous optical networks that carriers use to build, fiber rings to connect people. From there, we sold the company. I went on to work for Sprint in the government systems group. I worked for Rogers, which is a major carrier in Canada. And then I, the last 5 years before joining OneWeb, worked for Bell, managing their federal sales team and about $500 million of business. And increasingly, what I got involved in was complex network building, where it became very apparent that we were never going to be able to actually fiber everything that needed to be properly fibered. So in addition, I suppose, to the hands-on connecting individual consumers with cable and that sort of thing, I kind of got into the mega scale of fiber building in a very vast geography. And to highlight Canada's connectivity challenge versus what Brandy had shown us for, Colorado, what Alison has shown us for the US, Canada has at least a couple hundred satellite-only communities where there is no other option. And you can kind of see the density in the blue is quite low in terms of penetration. And even sometimes the distances between 2 major centers are completely unconnected for cellular service, or maybe you get some 3G. So we actually, I think more so than the States, due to lack of other choice, have really pushed the envelope in terms of satellite. And so, using, frankly, satellite to connect rural areas is not a new thing in Canada. It's actually been going on, I'm sure, Michele from Telesat will tell you forever, basically. Probably the advancement now is that with LEO, we have more supply. And so all of a sudden, in addition to maybe the C-band that you were using for this community in Resolute Northwest Territories, all of a sudden now you can get, 100 megabit connection through a OneWeb terminal. Similarly, in Pawlatuck in Northwest Tel territory, Northwest Tel being the carrier for Northwest Territories, they've built LEO into their network alongside other C-band resources. And via existing DSL to the home infrastructure, we were able to increase, broadband to the home up to 10 times what was available through a shared C-band connection. And of course, you get lower latency, so you can do more. So we've gotten notes from people saying, hey, YouTube is really cool. So, there's some just very basic connectivity challenges we've been able to surmount. What I've learned anyway through the years, and this is very much a targeted conversation around maybe insight I would have, having built both fiber and being a participate in the satellite economy, is that carriers really look to invest in high EBITDA services like cellular in particular. The capital markets really reward dividends paid for by the EBITDA that cellular services drive. And so a reality of the market is carriers will first look always to invest in places that drive more EBITDA. And so subsequently, there isn't as much reward for building fiber to the home. What does happen in a lot of cases when carriers are going out to build infrastructure is that they will pass houses, schools, grocery stores, whatever, on the way to the cell tower. And so they then will fundamentally connect those communities. But what it rewards is the density. And actually, I think we've heard this a couple of times already today. If there is no density, there is no EBITDA, and therefore there is no fiber for the most part, unless it's subsidized, which is where the funding programs come into play. What that strands in a lot of cases is services that are predicated on copper, such as some cellular services outside major centers, and a lot of the first responder infrastructure, frankly, that is vitally important to public safety in small communities. And you sort of feel that when you drive anywhere down a long highway in the US and you get into 3D coverage, which I just did last week when I was visiting. And so it's not really just Canada being a wide open space. Even in the US and some fairly densely populated areas, you still have a drop off in services because of lack of fiber density. So it does raise a question, which in terms of how to best serve citizens, that I've kind of come up with, and maybe this is the novel insight I would offer, is that I think in some of these communities, based specifically on the amount of capacity we have, I've been wondering whether or not we would be better off focusing on cellular backhaul with a combination of LEO and GEO to enable more 5G services, because you can get directly into people's homes, but you can also get into people's cars who are traveling, where highway safety could be an issue. You could enable maybe point of sale services and that sort of thing at a lower cost, and for a co-op in a small town, what have you. And so there's an overfocus potentially from the funding programs on connecting people's houses, but I think the person with the device in their hand might also be a target. Where the grant programs kind of come into play, it's always, certainly in the case of BEAD, in the context of connecting 100% of the population. The way it's kind of working now, and there's, I think, a misunderstanding potentially if you talk to the NTIA folks, they are willing to accept satellite as an input to a round one grant contribution application. But I think a lot of the states are of the mind that you have to exhaust fiber first before you can circle back and ask for OPEX money for satellite. In any case, what does tend to happen is if you have some form of connectivity in the community, often if there is copper, for instance, you're more likely to get the money to overbuild fiber. And because that fiber money is basically decrementing the total amount of aggregate funding available, what often ends up happening is people get to the end of the cycle and people who are completely unconnected remain unconnected. And so instead of starting with the completely unconnected people and trying to find a solution, which frankly could be satellite in this context, you'll often wind up with the unconnected remaining unconnected, and then the people who are partially connected just get a better fiber service. The other thing that we notice happens is nobody likes to pay for insurance ever in any context, personal life, business life, whatever. A lot of the fiber that gets built using grant money is linear because sometimes the costs are extraordinary. So unlike the ring that I told you I helped build when I was a young man, often the fiber that gets built in these situations does not have any resiliency. There is no ring architecture. You'll get the lowest cost fiber bid being rewarded to build into some place, and then nature will take its toll. And this year in Alaska, there was a major fiber cut of some quintillion fiber, which stranded a lot of communities. Thank God for Starlink and OneWeb, because we both put terminals out to restore service. Yellowknife in Canada, there was a massive forest fire that destroyed tons of fiber, both aerial and underground. Again, we were installed in their infrastructure. They had survivability. And we all know what happened in Hawaii. If you're starting to look at some of these smaller communities, a lot of the time it's in mountainous areas, coastlines, places where you could have forest fires, whatever, floods, you name it. And so I think the resiliency factor in a lot of these BEAD grants actually hasn't been taken into account. And frankly, any satellite service would be, I think, super valuable in terms of making a proposal for a survivable service. But what ends up happening though, I guess sort of in a broad sense, and what I see happening a lot in both Canada and the US, is that because of the preoccupation with building fiber, and often because that fiber gets overbuilt into places that already have some service, that there are a lot of the citizens with the highest socioeconomic risk factors get left behind. So if you look at Indigenous communities in particular, there's super high rates of incarceration. And because of a lack of just social resources, access to education, other opportunities, high cost of healthcare, you wind up with a high social cost that you end up paying, even though the fiber, grant didn't work out and there's no money left for satellite. You leave people unconnected, you end up paying for it in other ways. And so I think one of the major changes that we would recommend is that operating expenses, like a monthly satellite subscription, regardless of whose it is, actually should be part of the grant structure for the most underserved. Otherwise, you just end up paying for it, like I say, in a different way. So that would be one nuance, is that risk does not go unpaid for in other ways. We do have services live in Alaska. This is on the roof of the ACS offices, and we were in 70 communities in Alaska. The way we normally go to market, and I'm going to blow through this really quickly, but always happy to talk to people after, is if you have existing geostationary capacity of any sort, we recommend you keep it. We've recommended that in Canada. We say don't take out Telesat, add OneWeb to your existing community distribution infrastructure. We will increase the amount of available capacity and we will provide more resiliency to your community. This has worked super well. Equally with rural cell backhaul, when that quintillion fiber cut happened, we ended up carrying a ton of cellular backhaul. Worked really well. Actually, one of the customers from OTZ went on to LinkedIn to say, hey, I just did this and it worked really well, which was super handy. One of the things we have in our network is we have service level agreements. We have committed information rates, which is basically just a mechanism to guarantee service. We're a private network, so we can control the behavior of traffic on our network. We can physically and logically separate traffic for security reasons. So depending on what you're trying to do and how you want to do it, we act more like a carrier than we do like an ISP, and that's a major distinction. As a consequence, anyway, what we are able to do, whether it's a business or a community, is that again, we can put a terminal, in basically any location on Earth. It's the same value proposition as Starlink, really. And in fact, in some cases, we've gone side by side with Starlink. And so we would say, hey, they have a ton of capacity. It's cost effective. You should use that. You should also use us. So it's not a win-lose proposition. I think having more capacity, frankly, is a win-win thing. How it manifests itself anyway, always at the end of the day, is how it helps people. So on the left, we have a guy we were doing a video in Akiak in Alaska. This guy's four-wheel vehicle broke. And he said with the help of the internet, he was able to figure out how to fix it instead of not being able to run it for 4 or 5 months until he could get repairs done. And there are a whole bunch of stories like that that you enable when you connect people. And I think everybody on this call would inherently understand the value of being connected. The one nuance maybe I would add that isn't always as obvious is maybe the person on the right who has the general store. And same deal in Greenland and Northern Canada. Sometimes the community will have other infrastructure, whether it's government-oriented infrastructure or whether it's a major employer. You need to connect the whole community, not just the households. And so I think in the context of solving the digital divide, because of some of these areas being so high cost or socioeconomically challenged, if you do have a program, again, we would say you need to have an OpEx program that compensates the entire community, as opposed to just the households. Otherwise, you might, have a socioeconomic disadvantage for the employer and might limit their ability to grow their business or do their research or run their hydro plant or whatever it is. So blasting to a conclusion here, we would say, again, satellite, it's already having an impact. It has this geostationary forever. LEO is changing the landscape, and we presume will be even more impactful over the coming months and years because Starlink is adding more supply. We're going to do a second generation of our network within 5 years. Telesat will launch. Kuiper will come into play. We think building the local distribution infrastructure in communities is a good CapEx investment that you can plug multiple satellite providers into to blend and offer a robust service. And so we always say, look at every connectivity resource available. We think the one-to-many model works super well from a business context. And again, look at connecting the broader community against institutions. And the last thing that I hadn't commented on, but I think does bear mention, is that in places where people are truly unconnected and the grant programs haven't offered any sort of OpEx relief, often I find that there's a metric like a 50-10, or there's some SLA metric or something that is actually preventing people from taking advantage of the capacity that's available. And I would just implore anyone from government on this call, or go tell a friend, that sometimes that stuff is just counterintuitive and doesn't help anybody. And so, you know, at the end of the day, if you're going to, again, bear the cost of healthcare or other societal factors, way better to have people connected than completely unconnected, because you're going to pay for it some other way. So just trying to be practical maybe about that recommendation. And that is it for me. I will stop sharing and pass the baton.
Great. Well, thank you very much, Howard. So our next speaker is Michele Beck, from who's a senior vice president for Canadian sales at Telesat, and she'll be talking to us about ongoing Telesat initiatives. Michele?
Good afternoon. I'll pull up my presentation. Can you see that?
Yes.
Thank you. Thank you very much. I'm with Telesat. We are a global satellite operator. We've been in business for over 50 years, providing satellite connectivity from coast to coast to coast in Canada. We became a global satellite operator in the 2006 timeframe. We currently offer broadcast services to some large DTH customers throughout North America, including Dish Network in the US. The other 50% of our business is enterprise focused, providing connectivity to carriers, resellers, integrators, as well as government customers globally. We also have one of the largest consulting businesses worldwide focused on satellite connectivity. So we earn just shy of $750 million over our current geostationary satellite fleet, and we are moving to offer LEO services in the near future. So why are we pivoting to a LEO solution? So we've worked very closely with our customer base, and they told us a number of things over the course of the last several years. One, that they are moving a lot of their applications to the cloud, and that they are relying on 5G applications, which all require low latency connectivity. A lot of the applications today over the internet are securely encrypted. Our customers operate using VPN networks, and they require low latency to be able to operate effectively. In addition to that, just to ensure that there's a high quality on the performance of those links, or high quality, I guess, in the reception of the content over those links, and it's to be able to receive interactive content. So video conferencing like we're doing, so real-time video, actually video streaming over geostationary satellites, it's the perfect vehicle for that. It doesn't matter if there's a longer latency to streaming video content. What matters is the interactivity. So you want that very fast reaction. So LEO really has compelling benefits over geostationary satellites. They're 36 times closer to the Earth, as we actually heard, and they actually operate about 20 times faster to get that really essential connectivity from the cloud for VPNs as well as 5G services. We've heard that LEO constellations are a little bit more cost effective than geostationary satellites. They certainly have unparalleled resiliency because they operate in a proliferated fashion, which means there's a number of satellites that are operating as part of the constellation. And so you've got backup built into the constellation. Our service operates as a virtual fiber link, and the network is highly scalable. A lot of governments around the world and companies are now pivoting to low Earth orbit solutions for all of these reasons. And so it was compelling. Telesat decided to pivot as well. So we do view LEO as a new tool in the carrier's toolbox to connect not just remote communities, but to connect enterprises, any site that is truly off network. And also, though, to provide backup connectivity to those sites that are actually on network, connected via fiber or connected via any other means. So LEO operates very cost effectively in low density areas where it truly is uneconomic to either deploy fiber and or microwave connectivity. LEO actually is more of a broadband service than traditional geostationary satellites, and in fact is even more efficient and cost effective than the MEO satellites with our medium Earth orbit. So how do we plan on bridging the digital divide, and what approach is the one that most countries and most communities should prescribe to? So we view this that optimally there should be a mix of technologies. There isn't a single technology, a single winning technology that you should rely on to connect underserved, remote, rural parts of any country. Terrestrial wireless has its role to play. Fiber has its role. Enterprise satellite or geostationary satellite or LEO satellite offering enterprise-based connectivity solutions. And then there's consumer satellite, which is sort of the direct-to-user Starlink model or version. And it all depends on the makeup of the community and the area that you're trying to serve. So when there's extreme low density, and it's a single user out in the middle of nowhere, consumer satellite solutions is probably the way to go. You're at a cottage or a fishing camp, you're in the middle of nowhere, you want broadband connectivity, go for the consumer satellite option. You're in a higher density area, it makes sense to drive fiber. If you're in an area where you need a lot of wireless connectivity, then cellular backhaul is probably the way to go. You could microwave from tower to tower and then broadcast out from there. Where we come into play, and our model essentially is providing backhaul enterprise grade connectivity to cell towers, to communities, and we'll describe what that is. We call it the community aggregation model, with the goal of providing the most affordable connectivity that can meet some of the basic service objectives that are established by the various countries. And we know that in North America, they're actually striving for 100 by 20 megabits per second. That's kind of increased from either a 25 by 5, which was the US standard as of late. In Canada, it was a 50 by 10. And we actually see most of the governments now moving towards 100 by 20 megabit per second per household target. Quality of service is critical, and most of the governments are now establishing key parameters that need to be met. One of them deals with the latency, deals with some jitter, deals with the availability. They want it to be highly available. They want it to be robust. What they're looking for are technologies that can operate with the high availability that typical fiber does in very urban settings. And that will support, I think, 5G connectivity as well. That's very important. So the model that we prescribe is called the community aggregation model. So with our LEO constellation, customers will connect to the internet or to the core network at a POP, the point of presence. We'll get connectivity through the constellation itself, through a landing station or a remote terminal that is located in the community. That remote Earth station has been designed with a level of redundancy and resiliency. Again, we've consulted with our customer base. We understand what it takes to provide a high quality, highly resilient connectivity to connect these communities. And again, as Howard had stated, we're not just about connecting consumers or households. We're enabling the entirety of a community. And so we're here to connect enterprises, schools, hospitals, any type of institution that is located within the community. We're here to connect households as well as a 5G LTE or a 5G tower, so that the residents of that community can also operate and access broadband connectivity when they're outside of their homes, when they're wandering around the community, where they're on the highways driving from community to community. And how do we do that? Our constellation has been designed with a fair degree of flexibility, making use of state-of-the-art technology. And we can deliver gigabits, if not multiple gigabits of affordable, high quality, high speed backhaul broadband connectivity to the communities. We partner with local ISPs or carriers to connect the entirety of the community. Sometimes that's done through wireless technology. Sometimes it's done by fibering all of the homes in the community to that local POP that resides in the community. Sometimes it's making use of just other technologies such as white space or unlicensed spectrum to enable the connectivity to every business, institution, and facility that requires broadband. We actually enable it through the lowest cost solution possible. And how do we do that? So we recognize that what we're delivering is an enterprise grade solution. It's carrier grade. Communities want connectivity that is extremely reliable, that has a very high availability. And so we're getting ISPs, the local ISPs, to manage the connectivity and the satellite capacity, the megabits, the gigabits that land into those communities. And they can manage that. They can set all of their own controls. They manage it as if they were managing it over a fiber network. And we call that a smart VNO, virtual network operator model. we've architected our solution to actually be fully MEF compliant, Metro Ethernet fiber compliant. So it mirrors, it matches exactly what they would receive over a fiber network, and if they were dealing just with a fiber carrier. And it's important to note that not all LEO networks are designed with that type of connectivity in mind. Like I said, we've been in the business for 50 years. We understand very clearly what customers are looking for in terms of a service and the type of network connectivity that they need to connect these rural, remote communities. And that's what we've built with our Telesat Lightspeed Low Earth Orbit network solution. So we can meet the most demanding user requirements of enterprises, of the carriers for reliable, highly secure, highly throughput, low latency connectivity everywhere. Our Lightspeed network constellation consists initially of 198 very advanced satellites. We have a mix of orbits with the ability to scale. We've designed it for true global coverage with the ability to concentrate and focus capacity where it's required, delivering multiple gigabits, tens of gigabits to hotspots, which could be communities anywhere globally. We've designed it to serve enterprise and government customers and meet their very unique requirements. And we can deploy all of this cutting-edge infrastructure, bringing affordable high-speed internet and 5G connectivity anywhere. It really is a next generation network from space. Like I said, it's multiple gigabits of throughput to a location. A single terminal can provide 3.2 gigabits of forward capacity, 1.1 gigabits of return capacity. We support low latency communication, so sub 100 milliseconds. That's a full round trip to the point of presence. It's extremely low cost, so transformative economics, lower than multi-hop microwave or other satellite technologies. And how do we do this? We did this by incorporating some of the most advanced technologies on our satellite constellation and developing it with a lot of flexibility so that we can meet all of the demand in these hotspots so that we could use we use the capacity in the most efficient manner. It is truly plug and play, Metro Ethernet form compliant. So something that the carriers, that the ISPs that deal with fiber networks today, that they understand how to connect. It's a highly resilient and secure network with multiple satellites in the sky. We have inter-satellite links, so optical inter-satellite links that connect every satellite to each other. So in the event, if there was ever a failure of a satellite in the sky, we could technically route around that failure and connect with the next satellite in front of us. We have a complement of ground stations around the world that allows connectivity anywhere. Compatible with truly encrypted networks. So if you want to do your banking and you're encrypting your data, if there are government agencies that are operating in some of these rural and remote areas that need to protect the privacy of consumer data, they have the ability to do that and to operate seamlessly over the network. We have the ability to shift capacity to meet changing network demands. So if there was fiber that finally connected a community, that capacity could be sort of reconfigured and landed elsewhere where there is then currently a greater demand. So we do have the ability to shift that capacity around. And we've got true global coverage. We've been doing a lot of studies with agencies. And what we show here is that a LEO solution, when you combine both the CapEx as well as the OpEx for basically total cost of ownership to serve various communities, and you look at that over, say, a 15-year life where you would have otherwise amortized your fiber, that we come in at about 40 to 80% less expensive than building out to some of these very rural and remote communities. So it's a very compelling story. In Canada, we certainly did get a lot of interest, both from federal as well as provincial governments, in our capabilities and abilities to connect rural and remote communities. And one of the ways that they're even bringing the overall solution to more affordable rates, and for the ability to connect particularly Indigenous and areas where there are lower income households, was to commit to a pool of capacity. So they committed a large amount of capacity and for a long term, and that pool of capacity will go to connecting very remote communities where there is a high percentage of low income earners, and that's how they're subsidizing the broadband connectivity so that we can connect every household in Canada. And this same model can be used in every single country. And we plan on actually mirroring this program elsewhere. And that is basically how we plan on connecting many of the rural and remote communities, not just in Canada, not just in North America, but globally. So thank you, and happy to take questions.
Thank you very much, Michele. We'll defer questions to the end, but please, please post your questions in the Q&A session. And as I said, we've got time at the end to circle back to those. So our last speaker on the panel is Margo Deckard, who's Chief Operating Officer of Lynk Global Inc. And she will be talking to us about options for direct connection to cell phones and what capability that can bring to the mix.
Thank you, Alison. I am going to try to keep us on schedule because I would like for there to be a healthy opportunity for Q&A. So first of all, good afternoon. Thank you so much for your time. Alison, thank you for the introduction at the top of the workshop. I'd just like to add that I've spent the last 3 decades working in the humanitarian and defense sectors, and I am a retired first responder because I think that will help you to understand the filter through which I share Lynk with you. So while I'm sharing Lynk's origin story, I hope you'll look at it through the filter, one, that you know, whether you're a policymaker or a government buyer, that really technology, being technology neutral, technology agnostic is very important, but it's also important to future-proof because technology is developing at a rapid rate. And if you're planning some kind of timeline, like what you will achieve in 2027 or 2030, technology is going to just change the landscape and the landscape for the consumer before you reach whatever your build-out plans are. So Lynk was founded in 2017. It was born from the work that I did in the 2014 Ebola pandemic crisis response in Liberia and Sierra Leone. So while analyzing data from beacon units that were deployed to forward field hospitals, and those are Videosat terminals, I noticed that most of them are only ever texted from. And if you think about the information that can be conveyed in a text, whether it's infection rates, fatalities, or supply requests. And you think about the time saved if an emergency response team can simply grab their go bag and their phone and respond to a crisis, then you realize that the terminal is the problem. So together with my fellow co-founders, we designed cell towers in space that connect directly to that device already in your pocket without any modification. We're the world's only patented, first approved from orbit, and commercially licensed sat to phone system. On your screen in the turquoise box is actually Lynk Tower 1 as it deploys from SpaceX's Falcon 9 in April of 2022. So Lynk partners with mobile network operators. They bring the spectrum and the customers, and we bring the infrastructure to either fill in a coverage gap, extend their coverage, or provide their network resiliency. We do this by taking the terrestrial base station and moving it onto our small satellites in low Earth orbit and solving for Doppler shift, because now your cell tower is moving relative to you, and the extended range time delay, because instead of being 20 kilometers from your cell tower, you're now 500. So our cell towers are the weakest signal in the sky until a customer steps out of terrestrial coverage. Then all of a sudden our signal becomes the strongest and they seamlessly roam onto our network. So Lynk has 3 commercial cell towers in space today. We've proven the tech in 30 countries and all 7 continents. We've just under $3 billion in commercial contracts with 35 mobile network operators. September of 2022, the FCC granted us a license through the small sat streamlined authorization for the first 10 satellites in a constellation that's going to grow in both numbers and capabilities. We're also flying the world's first 5G cell tower in space. So here's Lynk's product roadmap. And while today, with the first 10 satellites in the initial constellation, we're offering intermittent services like SMS texting and emergency cell broadcast, we are next year moving to mobile money and push to talk, and then we're going to arrive at broadband in 2025. So this is a video that I'd like to share with you. We actually did this test in Mongolia. This is what an overpass looks like from space. So that's Lynk Tower 1. We could do 2 con-ups. We can either point at a specific location on the planet, or we can sweep the beam. And so when we point, that kind of looks like a terrestrial tower footprint. So all those little white dots you're seeing are 3GPP compliant devices that hear the Lynk base station and request to register. In this overpass, there's over 3,000 devices that request to register. But you could put any territory, whether it's Mongolia, or someplace in Africa, or even the East Coast of the United States, and you will see huge amounts of disconnectivity. And we connect to feature phones, smartphones, IoT devices, tractors. And now that you've seen what it kind of looks like from space, here's what it looks like on the ground. So this is a video that we did with our partner operator in Bahamas, Alive. This was actually done in their CTO's backyard.
Test Alive Bahamas 438-20-10-222147-813 Alive Bahamas.
So in the video, you're hearing the emergency cell broadcast, just like you do when you get a presidential alert or an emergency CB here in the States. One of the interesting things about the 3GPP protocol is when it reads out the emergency cell broadcast, it will also do that by whatever language is indigenous to the country, in addition to English. So there's a lot of flexibility within the protocol that governments and policymakers can take advantage of. And then the last video I'd like to share with you, while we currently don't support voice and won't roll that out commercially until the constellation is built out, I wanted to show you that the future of this type of connectivity is really here right now. So this is actually a video that was produced by 2 Degrees, our MNO partner in New Zealand. They went to a rural area and then they tested voice.
So So we're in Hanua Regional Park, which is a pretty nice spot, but we picked it because it's got no network coverage. So you can't normally make a phone call out here. We're going to try one via a cell tower in space.
Hello, Brendan. How are you doing?
Hey Dave, can you hear me?
Loud and clear, mate, loud and clear.
First call over satellite in New Zealand.
Casual groundbreaking kid milestone for a morning.
Hey, do you want to hear a dad joke? It's pretty cold up in space, but it just got
2 degrees cooler.
Too cool.
So what I love about that commercial is you can kind of hear the satellite as it moves across the overpass. You can hear a little distortion, and that's actually the impact of being at the edge of the test. So before we start our Q&A, I just kind of want to leave you with a couple of thoughts. So in 2022, Yellowstone National Park actually had to shut down due to unanticipated flooding and evacuate 10,000 visitors. Now, you're not going to want to build out terrestrial towers in a national park. It's cost prohibitive, and it would mar the landscape. But what you do need to do is have some kind of connectivity in order to keep your visitors safe. And Lynk can do that today. It's not in the future. In fact, we're supplying emergency connectivity in the international market. And so again, if you're a policymaker or a government buyer, you know, being not only technology agnostic, but also future-proofing, because I think you're going to find that in the international market, the future is arriving today. And of course, we want our American citizens to be able to have that connectivity as well. And second, you have to meet the unconnected person where they're at. And I'd just like to touch on something that Howard said at the end of his remarks about that population that's living without nothing. And while I completely appreciate, you know, having benchmarks and the government saying you've got to meet this requirement, this download speed, there is an inherent danger to that. Because as a humanitarian, I will tell you, the digital divide is widening. It's not shrinking. We're leaving more and more people behind. The CDC, you know, they measure the number of people living in a household with only a wireless telephone. And in June of 22, they found out that 71% of adults and 82% of children live in a household with only a mobile phone. And those numbers are actually skewed towards populations in the South and the West, where we have the worst terrestrial coverage. And also, the reason why the CDC tracks these is because often these populations are the most vulnerable and sidelined among us. So they're usually the people who don't have access to healthcare, people whose health habits shorten their lives. So what Howard, and I hopefully not putting words in his mouth, but and what I would like to project into our conversation is, you know, what can we do for those people now? Because I can tell you by 2027, the digital divide will be wider. We really can't afford to wait 4 years. And there is technology available today that really can help address some of your community's digital needs. So thank you. And with that, I will pass it back to Alison so that we can have a discussion.
Great. Well, thank you very much, Margo. So that was an excellent overview. Oh, excuse me, I was unmuting again. Thank you very much, Margo. That was an excellent overview and exciting potential that new technology from space can deliver. So I'd like to open this up for the Q&A. I've got a couple of questions that are posted, and some time permitting, I'd like to ask myself. What I'll do is I'll pose the question, and if those of you who have would like to respond, please raise your hand, and I'll call on you each at the time. So the first question was posted by an NAE member who lives in California's Central Valley, and I think it's an excellent point for discussion for the group. So they say, finding affordable, high-quality internet is difficult here. Migrant workers and families living in grower-provided housing will never be able to afford fast internet needed for children's homework, remote learn, work from home, etc. Can the case be made that this is akin to the national highway system of the 50s and requires federal funding to build? Let's see. Brandy, I'd like to start with you. I saw you post an answer. Maybe you could just share that with the group.
Yeah, thanks, Alison. Yeah, I think a case can be made to scale it up to to the equivalent of a national highway system. And some states are doing that, on a local basis. I think the federal government took a different approach with the Infrastructure Investment and Jobs Act, the $42 billion for broadband funding there for NTIA and various other programs I mentioned earlier. They really wanted to recognize that, each state needs to craft their own plan and for how they're going to expand service. But I do agree. I think, if you're looking from a holistic approach, if you just build infrastructure or you layer broadband infrastructure on top of existing infrastructure, like in our roadways, rights of way, utility lines, everything like that, you can really achieve universal coverage pretty effectively from that, but it's really expensive. And, a lot of governments, they don't really want to, enter into the space of being an internet service provider. Some do and some don't, but like I said in my comment there, it's pretty rare. But, in terms of, the super highway that connected all of our country, and even if you want to even include railroads, the amount of commerce that we have and economic activity and how people are connected just through existing infrastructure, to your point, would lead to that. And I think there's a case for it, but I think really it's down to what each individual state wanted and wants for their locals. And so it's not a one size fits all approach, but we're seeing local efforts where they're doing that on a more local, granular level.
Great. David from SpaceX. David,
Sorry.
you're on mute.
Yeah, thank you. Sorry about that. So I do think that's an interesting analogy, but I think one of the things that I heard across all of these presentations is that we've gotten to a point where access to broadband is not necessarily the problem anymore. I think you heard from several different operators that you really have options of some pretty good, not just one, but several choices of some pretty good broadband solutions that go straight to your home. So I think we may have hit the point where paying for it like it's a highway system, like it's an infrastructure project, may not necessarily be the right approach anymore, because you do really just about anywhere you can get access to multiple options of good broadband. I do think there is the question of affordability though, right? And that is fair. These systems are extremely expensive, even at the lower cost that we can launch at now. Even with the economics having changed, I think Howard was mentioning it earlier, of like the economics of all of this have changed. Even with that, it still is not cheap. And so I think to the extent that there's going to be future programs, I really do think it's worth it for policymakers to be considering whether we can be applying that to affordability solutions rather than access problems. Because I think we may have closed the gap on the access side.
Really good point. Howard?
Yeah, so I guess to add to that, there's probably a couple of comments. The first is that the NTIA, we did actually meet with some of the leadership a couple of times as recently as the last 2 or 3 weeks, which I may have mentioned during the pre-session for this, but they're quite open to the states using satellite services to address, like I was saying earlier on, the proposals. I don't know that that's actually as well understood as it could be. And so I do think in terms of getting to 100% coverage, it would be really great if the NTIA could clarify that position to all the state broadband offices so that it was abundantly clear, because some of them frankly just have no intention of applying for subsidy because they don't think they're allowed to, which is kind of weird, even though we've said, oh, you should call and go and make sure you're not missing out on an opportunity, because I think some proponents might like actually apply for it and have a superior proposal, whereas others maybe who are applying may not, and then not have 100% coverage in their round one proposal. I think the affordability thing is sort of comment number 2. So there are some communities, certainly in northern Canada, where I've spoken to people where there's no connectivity in the house whatsoever, including a working telephone. And so they've had, in some cases, people die because they couldn't call the midwife, which is pretty heartbreaking when you run into that sort of conversation as reality. And so in some of those cases where we were running up against, just frankly, a lack of usable capacity to meet a 50-10 for every household in the broader community. There still, in some of these places, half the household unconnected completely. The other half had something at least. We kind of ended up taking the approach that maybe trying to, again, connect people through cellular infrastructure was better, because in the households, they will tend to prioritize paying for a cell phone over their hydro bill. So some of these communities have an 80% default rate on their electricity bill, but they're still going to pay their cell phone bill because they, when they go into town or whatever, they might be able to use it, which is kind of a weird thing. So we wound up talking to an Indigenous chief who said, yeah, I just want to be able to sit on my couch and use my phone, whether it's connected to a Wi-Fi thing in my house, I don't care. I'm still going to pay my $50 a month for my cell phone. And as soon as you start to get into that form factor, what you realize is maybe you don't need 50-10 to a cell phone in order to use a banking app or something, and it's more pragmatic just to give people some basic connectivity so they can participate in society somehow. And so I don't claim to have a full solution for any of that. It's just an observation based on conversations we've had that maybe there's maybe Margo's solution is amazing and she gets subsidized because it provides more ubiquity or something. I don't know.
Thank you. Margo?
So just kind of to add one, Lynk's a little different. So, and it becomes from a place of our humanitarian and mission focus. We don't want a subsidy. We price the end service so that the consumer can afford it. So if you're in the Central African Republic and you make $60 a month, you can afford the service. I think that's really critical. And I'll tell you, I've worked on a lot of projects, and subsidies can be very hairy. One, it kind of speaks to this whole rollout of the broadband services, and kind of to echo somebody's question about, well, should it be a government program? Should it be a national highway? And then David commenting, well, there's service providers already. So how the government chooses to spend its bucket of money to get connectivity to people, I think, again, should be agnostic. You get this bucket of money. There are providers who can service your citizens, so purchase it on the open market. SpaceX is actually a great example in those launch vehicles that David showed us. So the United States government, the way we get to our International Space Station is using a commercial company called SpaceX. The United States government could not fund the government development of a rocket to get to the space station affordably. That had to be done by industry, and it was done by SpaceX. So I think when you look towards broadband and you look towards the providers currently out there and how to spend your money most effectively, invest in just writing the contract to that company so that they can provide the service. And I really wish that the government would get out of this whole idea of necessarily think of this as infrastructure build out. Really buy the services on the market, spend your money that way, write service level agreements in order to get the services quality that you need for your consumers.
It's an excellent point. We have another question posted that kind of plays to that, which says, should public dollars be used to support the rural broadband initiatives, where public dollars can usually only be spent for capital expenditures on broadband grants? There's been arguments that LEO's operational costs should also be covered, which I think plays exactly to your point. Before I ask the panels to answer this question, and I'd like to phrase it in terms of, if you ruled the world, or you could rewrite the rules currently for the federal funding, what would you recommend specifically be changed to address this OPEX CAPEX mix? And Brandy, I'd like to start pivoting back to you. And in particular, what I was thinking about was we have an affordable connectivity program. It's an SEC program to help low-income households. And of course, part of the issue with the rural divide is it's not just access to broadband, as it was mentioned. You know, we do have space coverage, but we have an affordability gap. And the affordability connectivity program is designed to help that. But of course, it's not approaching the levels that would be needed to give access to these disadvantaged communities, to the space services. Could you talk a little bit about that program and how maybe you could see it could be adapted or enhanced to bring space into the mix?
Yeah, I think, I do think that there's an opportunity to bring space into the mix, from our perspective in Colorado, when we look at internet affordability access, again, we're looking at it from across different technologies. So it's not just the infrastructure, fiber, towers, a fixed wireless, but space as well. I think where the federal government, could, what they could consider is subsidies for all the technology. And so obviously, the Affordable Connectivity Program is a huge deal for us in Colorado. About 30% of our population, 30% of those that are eligible actually subscribe. And, it's 44% of the issues why, and when we've surveyed people, it's 44% of the issue as to why people don't connect. So these folks have access to the internet, but they don't connect because they can't afford it. So whether you have access or not, it's the affordability issue. And I think what I would love to see is the subsidies continue, but also include different technologies as well, because those are important. And when you look at the most cost-effective way to get to these rural places, I think, like I said earlier, space has a role to play. And to me, space is an internet service. And I feel like, we're missing an opportunity there, because when you look at rural Colorado, and I'll just speak to rural Colorado, I'm sure this is true across the nation, is rural residents paid disproportionately higher prices for services at speeds that are much lower than you can get in urban areas. And so, I think there's a case to be made for, looking at different technologies and subsidizing those. And I understand the whole idea of, leaving it to the free market and pricing your services according to affordability. But if we did that in rural Colorado, everybody would pay $400 a month. And so it has to pencil. And I feel like there's a role for the public sector to play in that space to help bring down those costs. And so, at least the upfront cost, I know space technology is it's a little different, same outcome in terms of speeds and connectivity. But I do think that the subsidies are a huge deal for us. And when you look at the urban areas, those people have access, and they don't access it because they can't afford it. They're choosing to pay for groceries over internet. And so I think, there's a real case to be made for subsidizing space. And on the OpEx side, we are, and I'm answering a couple of questions here, but, we have the funds are being applied to the actual capital infrastructure, the cost of the infrastructure. But what I feel like the federal government could do or should consider is especially for rural areas where that OpEx, you're not going to break even for 5 to 7 years, which for some industry, providers, ISPs, they're trying to break even in 1 or 2 years. And that's based on their performance. But we should have a conversation around, okay, if we were going to consider an OpEx subsidy, at what year, how many years do we offset those costs so that those networks can be more financially feasible and viable over the long term, so they don't fold, because that's also an issue with previous federal programs as well. So there's a lot in that answer, but I think affordability has to be half of the equation for access to broadband services.
So Alison, if I may, I don't think affordability.
Go ahead, Margo.
I'm sorry. I think affordability should be at the forefront, right? So most of my experience is in the international market, and I will tell you that in the case of the work that I did for the Ebola pandemic, a crisis response, Those programs were funded and subsidized for 2 years. And the minute the subsidy went away, so did the connectivity. So when you think about how you're going to, for your citizen, get them integrated into our social and digital economy, I think you got to be careful where you decide to put those subsidies, or how it is, like if you give them the purchasing power to go onto the market and get their connectivity, where the power is for that, and where it is that you build competition in your market, like in this case for broadband, because you put the purchasing power in the consumer's hands, and that they can go spend that subsidy, and they will truly be technology agnostic, because they aren't being lobbied, they aren't influenced by that. They're influenced by, they just want to go to the faucet, turn the faucet on and get water. They just want to sit on their couch and get connectivity on their couch. So I really would encourage policymakers and government buyers to really think about how that dollar is being spent. It is absolutely wise to spend that dollar for connectivity, but how should we spend that in order to get the most for our citizen today, and not just at the end of 2027, when you're actually connecting, as Howard pointed out, the most vulnerable populations are the last to get connected. So I just want to really think about that word subsidy and what that means, because it has a lot of power, how you spend your dollars.
Very good point. So I'm going to go to Michele, and I hope we can run a little over, because we're having some very good conversations here. So I don't plan to cut anyone off. Michele?
Yes, sure. So in terms of affordability, I mean, we've seen different models used to ensure that services are in fact available to some communities where otherwise it is completely uneconomic to serve. And for a couple of reasons. One, you can't affordably build out the infrastructure in some of these locations. Two, the population can't afford to pay for it. And so there does need to be a government subsidy in some instances to actually just even simply build out the required infrastructure, and two, to then subsidize some of the ongoing costs. We've seen programs where governments have covered both. And so they capitalize the whole thing. They capitalize any type of infrastructure that is required, but they will also capitalize the operating costs over a 15-year term. And that's the way, that's how they get around just the funding the OpEx. It's viewed as CapEx in its entirety, and it's for a long term, 10 to 15 years. And that would be sort of the amortization period on a typical infrastructure build anyways. And so we've seen that as options in many areas. Otherwise, the services will not be available. And to think that there can be huge competition in many areas, it's difficult when even you can't even support a single service or solution. And so in some areas, governments need to be a little bit more pragmatic. And there's a reason why service isn't there. It's because the ISPs, the carriers, can't even afford to build out that infrastructure.
Thank you. Howard?
Yeah, I guess in terms of just the whole notion of how subsidy is granted, there was a thought process in Alaska that there was going to be like a bucket of money for a whole bunch of tribal organizations through the NTIA Tribal Broadband Program, and didn't really ever materialize exactly that way. But one of the things it did highlight was the risk that when you get into some of these environments where you have a small cooperative or consortium of people bidding, you might actually get some success constructing the asset. But a lot of the time, the long-term business plan just sort of falls apart. And what you see in certainly lots of these programs is that the carriers, again, won't go near it because there's not enough EBITDA. It's not core to their business. I actually just had this conversation with one of the big carriers in the US last week. And they said, unless it's $1 billion market for us, we're probably not really going to go too hard at it. So their cutoff was, $1 billion in revenues with 40-50% EBITDA, honestly, which is including subsidy, which is kind of an interesting model. So what it does, though, is incentivizes smaller players to sort of jump in and try to build. And I know that in the audience there are some, I think, people who represent some of those organizations who are quite good, by the way. But I think I've seen in Eastern Canada, for instance, some of the smaller communities get together, try to bid, they get the grant, then they can't operate it, and then it becomes the asset of one of the carriers for 25 cents on the dollar. So there is a sort of I think realistically a need. Like even my family's company that had 265,000 subscribers, we ended up selling to Rogers because it was the best economic outcome. There wasn't any way to support the capital infrastructure investment required, even with a subscriber base of 265,000 subscribers, for what it's worth. So I do think that there's like a heavy ongoing OpEx strain involved with maintaining and managing these networks into perpetuity. And unless you're an expert at it, it's very hard to do properly, is kind of my comment. And then I guess subsequently, you do get into the affordability thing. Do you give the individual the subsidy almost to the household? I've seen some of that in Alaska as well. Actually, that can work quite well. So, if you said, here's some money, you can either buy it from the local ISP, you can buy it from Starlink, whatever, that might be a different path to the market for what Margo is talking about. And by the way, I love the business model you have where you just make it affordable. That's amazing if you can pull that off. I think for both Telesat ourselves, I'm not sure about Starlink, like we're getting government subsidy. Like we have governments kind of, they're like UK government's a shareholder of ours, French government is a shareholder of ours, government of Canada is effectively a shareholder, Telesat. I think Starlink has, multiple other lines of business supporting it. And so it's just the sheer cost of getting into orbit is so high that you almost wonder without some sort of additional support whether or not you'll even have the service. So I think that's, whether it's direct subsidy or somebody's paying for you to get into space, there's definitely help required.
Well, Lynk has a unique advantage because we don't have a terminal.
Our
terminal is the $5 feature phone or the $1,000 iPhone. So it is the terminal. I agree that that is expensive and cost prohibitive because I can build cheap satellites, and David gives me very affordable access to space, but awesome. I don't have to subsidize a terminal. I don't have to pretend it costs orders of magnitude less than it really does.
Yeah.
So it's different. It is a different economic structure.
Let me jump in on that, because we've had a common theme, I think, with multiple of the panel members, which is, what is the right number for broadband? Obviously 100 megabit per second, lovely, but that's going to be expensive, whether, no matter what mechanism you are, and is it ever going to be affordable? Then we've got the other end of the spectrum, which is getting down into what, even 3G. 3G was a miracle, when it first came out, and still would be in a lot of very rural areas. And a lot of Colorado, we don't have cell phone coverage, which is not just a broadband access issue, it's a safety issue. I mean, there are lives that are being lost because we do not have cell phone coverage. So can I ask each of you just to comment briefly on what you think is the right size? Because we've heard different options for using virtual networks to expand 5G, going direct from space to 5G, and in particular for rural and affordable areas. Should there be a push maybe within the community to say, back off? There are solutions that are good enough, and there should be more investment being made in them and expanding 100% access. So let me just go briefly through the panel on that. So David, since you're first, would you like to comment?
Yeah, sure. And I'm going to have to apologize that I think I'm going to have to drop after this answer. So sorry about that. Yeah, I mean, it's a hard problem, right? Because you don't want to say that somebody, because they're in a rural area or another area, gets second tier broadband, right? At the same time, some of these pushes for speed, frankly, are not really based off of any data of what, I mean, when people are talking about they need gigabit symmetric speeds, there's just never been any evidence that that's true. That seems more based off of trying to stop competition than it seems based off of actually trying to serve what consumers need. I personally think 100 megabits is not that far-fetched to be able to require, especially if you're going to tie it to something like subsidies. I get it, because you don't want to then turn around and say in rural areas that you're just going to be subject to worse broadband. But it is a hard problem. I do think that it's probably worth kind of looking at real data, real consumer data. What do people actually need? And potentially based off of that, setting up programs with performance metrics rather than technology mandates, or also avoiding technology mandates disguised as performance metrics. So I think that like 120 is not that crazy to ask for. But I get the point. But when you do start getting into these hundreds of megabits and gigabit symmetric requirements, it's just never been that way. And just to give you, just because we're all heavily dependent on spectrum, the FCC does not allocate spectrum symmetrically because people don't demand spectrum symmetrically. If you auctioned spectrum symmetrically, you would not get as much on the uplink. Providers would not bid as much for uplink as they would for downlink because people need more downlink. So sometimes I think these speed discussions are not based off of what consumers need. And so I don't mean to be dodging exactly what the answer is on an exact number, but I think basing it off of what consumers actually need as opposed to marketing is probably a better idea for like when you're talking about government programs.
Howard, would you like to make some closing words?
Actually, just to sort of add on to what David was talking about, it also depends on what you mean by 120 or what have you. How carriers produce an ISP service is kind of magical. And just as an anecdotal thing, in Mantissippi Cree First Nation in northern Manitoba, we put a test terminal in. 50% of the homes had no connectivity whatsoever. 50% of them did. I think there were probably 75 households maybe on the network. We put in a 75 megabit dedicated connection, which is like contended bandwidth. And those households, and it might even be as low as 50, pulled down 13 terabytes of data over the course of a month trial. We left it for several months just to see if it was, sort of continuously being used that heavily. And it kind of forms my opinion that when you are unconnected and somebody gives you a reasonable connection, it feels like you're connected. I think part of the issue that we get with the regulators is that, in downtown urban areas, you've got, like, certainly in Canada, I got Bell Canada ringing my doorbell trying to sell me a gigabit access for my wife, my cat, and like, we just don't need it. So I'm trying to pay for the 100 megabit connection because I don't want to pay for more. It's just not required to run my household, even with my connected stuff. So we have a tendency to overmarket internet. And so then it creates this false impression that everybody needs tons of it, when in fact, there's a limit to what a household actually practically is going to consume. So I think in all of that, I would just advocate, again, if there's a resource available and you can connect somebody for lots of good social reasons and economic reasons tied to that, the government should look at trying to be more flexible in terms of how they connect people.
I think it's a dilemma that governments are debating and working with. It's a standard per household, not a standard per individual, and there are multiple people living in a household. During the pandemic, they were working remotely. They were going to school remotely. Everyone was using video conferencing and forms of video streaming. They all had VPN devices. It all required high bandwidth connectivity. And so, end of day, a 5 or 10 megabit per second link didn't function well for a household which had all of that demand and all of those multiple devices. And so the governments are looking at keeping pace with technology, keeping pace with applications, We do know that a lot of the schools, municipalities, they're moving all of their services to the cloud. So it's no longer that all of that data gets processed locally. Everything actually has to go south to these large data centers. And it just requires more capacity, more data throughput than ever before. And so governments are mindful of that. It takes several years to kind of build out that infrastructure. So as they're looking to the future and trying to assess what that standard should be, it has to have some staying power, and they're envisioning what is coming down the pipe in terms of applications. So I think, a household now that has a target of a 25 by 5, which was the standard, is probably, barely kind of making it nowadays. And there's that target basic service objective data rate should be increased slightly if you want staying power over the next 5 to 10 years.
So Brandy.
Yeah, thanks, Alison. Yeah, I tend to agree with Michele. I think you should definitely, have data to assess, what consumers need. I mean, that's one data point. I don't think, or what they demand. It's just one of many data points. I think as somebody in the policy regulator space, we're looking at multiple data points as when we look at minimum speeds and setting policy in that. So I think the issue with using one data point where it's like, hey, we're only going to set speeds based on what people demand. Well, if you can only get 10/1 at your house, I don't think you can accurately assess what that household needs. And I think we over the years, and we've set these minimum speeds like 25/3. That minimum speed that the FCC set was tested during the pandemic, and for many of us who had been struggling with those types of speeds for decades, it never worked. And so I think you kind of have to look at what people are currently getting, what the future looks like, and try to have some sort of multiple metrics when you're looking at what speeds and demands. And I think that the government, I mean, we set standards all the time for different, for example, I'll take utilities. There's minimum standards for each service that we regulate. And I think not having at least some standards for broadband that at least meet what we think is today's need and have the ability to scale. Because even in these federal programs, you get more points and more subsidies for being able to scale up, recognizing that 100/20 is the standard. So I think the government's trying to look at different data points and trying to balance it. Like, here's the minimum, but we really want you to be able to scale up. You're going to get more funding that way. I think the regulators are trying to strike that balance with providers as well. So it's not a one size fits all, but you definitely have to look at more data points, because if you just take the one where like, well, what do people need? Well, I get 10/1 at my house. That's all I can get. So, it just you have to look at look at it from different angles as well.
So I'd like to just circle back on that point to Edward, who is, of course, a data analytics expert. And Edward, maybe could you give some thoughts on what might be next steps to maybe address getting better data on some of these subjects that could be used to inform, public officials on how to really leverage the investment to bridge this rural digital divide?
Well, back to data. I mean, data's been an issue for years. Obviously, the FCC has collected new data now to try to provide more evidence at a more local level about where that investment should essentially go. So we'll have to see if that kind of filters through. I haven't personally played with that data yet, but I did have some general comments on the discussion that's taken place so far, if I may just kind of put those in. So I think the first thing that I would say is that, if we had the opportunity going outside in, and by that I mean starting with the hardest to reach areas first with some of the subsidy programs, might be a good idea. And the reason why I say that is sometimes we provide subsidies to areas that the market could have reached about 3 or 4 years later. And we don't really want to be in that situation. So looking at intermediate technology solutions for them in some of those areas is always a good one. And specifically going where we know there's market failure. I mean, that's just kind of the reason of existence for welfare economics. It kind of fits well with our general approach to how policy should usually be kind of played out. I know at the end of the day, that's a political decision. And then I think my only other comment is on infrastructure sharing, which is that we duplicate a lot of infrastructure. And I don't think that always needs to happen. I know, again, that's a political decision to make. But in some areas where we can't even afford to deliver one network, it would seem potentially inefficient to try to deliver multiple all at once. So I'll leave you with that. Thank you.
Thank you. Well, anyway, we've run over, so I'll have to close this panel to bring this panel to a close. I would like to conclude again for thanking the fabulous National Academy of Engineering staff, Melissa and Amici, for their support, and for the National Academy for sponsoring this webinar. I've personally found this incredibly informative. I hope it will help inform some of the decision makers going forward. And I would like to thank you all for your time and your candid inputs. I appreciate that greatly. Thank you. Okay, well, we will just close this right now.
Thank
then,
you.
Melissa.
Thank you.
Thank you. All right, bye.
Bye.